So I'm John Tringham from OSIsoft. OSIsoft is a company that writes a software infrastructure for collecting real-time data off of sensors. So we're based in San Leandro, California, right outside of San Francisco in the East Bay. And we have customers all over the world. Our customers are in 147 countries, a lot of different industries. They're in large companies or small companies, and even in environments where we're in the academic setting like UCDavis. So we're happy to be partnering with UCDavis here and sharing their data up to the hackathon here so that you guys can hack on that data. An example of the size of the databases that we tend to have for our customers is, like, here's an example of CAISO. CAISO controls the power grid of California. They operate on about 1 to 2 million streams of data collected about once a second for 20 years. So who's the math major? How many data points is that? A lot, right? So usually when you talk big data analytics, a lot of times you're doing analytics on subsets of this data. And at Davis here, you might be doing that as well, right? Because if you're looking at a single building across 3 years and looking for a trend, that's kind of a subset of the buildings that we have on campus. So if you're interested in our careers, just go to our website, look up careers. We're looking for interns for this summer still. And if you're from Davis, we'll be up here next week with an info session on Thursday, as publicized by HackDavis, and then the following week for the job fair right here, probably. Our challenge is the best sustainability hack using our data. It doesn't count if you do a sustainability hack not using our data. So you have to use our data in our APIs. And this URL down at the bottom, we'll get to in a couple of seconds. This is where really the technology sits and where Christian will walk you guys through that information. With that, I'll actually turn it over to UCDavis, who will talk a little bit about the data that you have before you and a little bit about the challenges that they think might be before you for acting on this.
Hi everyone, my name is Kieran Salmon, and I'm short. Thank you very much. I work for facilities management at UCDavis. Stan.
I also work for facilities management in UCDavis on the energy engineering team.
Yeah, so our office is a group of energy engineers, data scientists like Dan. I am more on the project management side. I manage a few projects. One of them is CEED, which stands for the Campus Energy Education Dashboard. That is where the data also lives, that you guys have as well. On this website, you can kind of click around and see how building energy use is at UCDavis, how it differs by different building types. This will help give you some context to the data. If you need more of a description, just a background about the data, our campus works a little bit differently than a home would. So you'll see steam data. We use steam to heat the buildings on campus, and we use chilled water to cool buildings on campus. So you'll see electricity, steam, and chilled water data.
You need all three of those to make a picture for a building, because at home you have, let's call it direct expansion unit, like your air conditioning that's outside.
Talk in the mic.
Electricity. What's that? Hello? You can't hear me? So at home, your air conditioner outside uses electricity to cool your building. Here we use chilled water or central plant to then pipe to the buildings and provide that cooling to the building. So in order to really get a full picture, you need all three of those assets. Chilled water, steam, electricity.
And that information you can also find on trimthewaste.UCDavis.EDU. That kind of explains a similar concept. This is a screenshot of the dashboard. This is showing demand data. So you guys will have access to demand data, which is like real-time energy use in the building. And then you'll have access to usage data as well, which goes over certain intervals of time, like monthly energy use in the building. Okay. Oh, wow. So these some ideas that we're always curious about in our office, kind of finding new ways to analyze the data, new ways that we can save energy on campus. So let's see, energy forecasting. That's something that we're interested. Building benchmarking is like comparing our buildings on campus to each other just to see how our portfolio is performing. Or there are like national level databases where you can see how certain types of buildings are performing across different states. If you do look at buildings in other areas, it is important to consider weather normalization. We use energy differently in California than buildings in New York State would use their energy, just because the weather is different. From a project management point of view, I'm always interested in new user interfaces, things that we can end up adding to our dashboard, our energy dashboard, new ways that students can interact with data, or staff members as well on campus, just so they can be more aware of how our buildings are using energy. And then, so the right side are a couple of websites or just ideas where you can bring in data from a different source, like any other public source. Last year, students used CalISO data. There are a lot of government databases, or if you want to look at UC Davis specific data, there's a website called AggieData.UCDavis.EDU. This has a bunch of data sources like enrollment, class schedules. You can pull that data and kind of mix it with the building energy data to see what trends come up, what findings you can share with us. And lastly, Wi-Fi data.
Sure, yeah, so we have aggregate Wi-Fi data, connection counts per building. So it's not, we don't have like individual user ID information, but we have a total count of how many people are connected to the Wi-Fi using any device. So I typically have 2 devices. So if a building has 1,000 people connected, it might only be 500 people in that building. But we do have that for all of the major buildings across campus that we provide in, I think, an Excel spreadsheet that you can mash up with the data that you have. So that's going to be an option as well. If you have any questions about it specific to that data, I'm not talking about it.
So, basically the key questions, stem from the data. And so these are just some examples that you might be curious about when you get in and look at the data. Building to building comparisons or building age comparisons, different things along those lines. The primary class is like a keyword that says if the building is a research or classroom or maybe a different type of building, but there's different classes of buildings that you can see there. So these are just examples. We'll have these actually at our help table. Come by and talk to us about your ideas, and we can help expand them or say if they're feasible or not. Here's some examples of some visualizations that have been done in the past, whether it's a 3D rendering of buildings and which ones are using a lot of energy, or maybe even a detailed view in the middle there of that's an EV charger that somebody picked out on campus by looking at the detailed data for our building. On the bottom right is what's called a heat map. So that's basically all the energy for a building for a year in one display. So you can see if it's got trend analysis in there. On the left here is, or on your right, is just a different way of looking at that similar data. Here's some screenshots from hackathons past. So there's one up there that looked at the energy flows in and out of the buildings. The one on the right was an interesting set of analytics that looked at how the buildings were performing. Sorry, your left, my right. Your right, sorry. And going forward there. So now we'll actually get into the real stuff. You want to come up, Christian? So Christian's going to take you through the website, the OSIsoft.com/HackDavis. This is where the API is, and all the API keys will be as well.
Hi everyone, my name is Christian Foisy. I'm solution architect at OSIsoft. So, like John just told you, I built the API, right, to get to the data, so you have an idea about what's available in there, so how do you get access to the data. So if you've been already to that website, so it's academic.osisoft.com/HackDavis. We tell you how to access the data. And to show you the API in action, I will just show you the notebook that will be able to get access to the data. So here it's pretty much kind of a description of what the UCDavis report will do. And what you care about will be, for example, you were told that there was CSV data about the real-time market data for electricity. And the Wi-Fi data that was just mentioned, it's available there. So you just click on the link, download the CSV, and then you put it in the tool of your choice for analysis. But the data is there. So this is the CEED dashboard, right? This is what they're building and showing. So with all the data which is available through the API, you have all the information if you want to reproduce something similar. So you have the building location and all this information to rebuild something like this. So it's all available. So, about the notebook itself. So this is the link within that web page. So it sits somewhere on GitHub. So I will just go and open that up. So you may or may not be familiar with Jupyter Notebook. So this is just a bunch of cells with, yeah? What? How many people know Jupyter Notebooks? I like this. Okay, so let's go. So, this is write a notebook which has been executed already, so you see the output. So first, to connect to the data source, you'll need to install the package called HackDavis version 34, that's the best. You install it on your machine, and then you have the code for the access. The API is very dead simple, right? So you get, this is all the functions that are available through that package. So first of all, what do you need? The list of buildings. So you call the first one, you get the list of all the 159 buildings, I think, we have available. So pretty much the whole UCDavis campus. The second one, for each building, you may, like you were told, you need electricity, steam, and chill water. The problem, or what you should know, is that all the buildings have electricity at least, right? So for every building, they have electricity data. What they may or may not have is information about steam and chilled water. So you're calling the CEED.UCDavis function with the name of the building, and you get the list of CEEDs available: electricity, chilled water, and steam. So you have a building, you have a CEED, and now you need to have the time series for, let's say, a given building arc and electricity. So you're making a call to streams of, and out of that, what you're getting is the list of all the streams for electricity. So one will be demand, another will be demand in kBTU and things like this. So this is where you get the list of streams for a given building and a CEED. The fourth one, metadata. So each building has a bunch of metadata. So there's a code name for the building, latitude, longitude, and a bunch of other information that I don't know about, but those guys really know about that. So you look at the data, and if you have questions, you come to the OSIsoft table, and we'll be able to answer those questions. And then, so you have the building, you have the seed, you have the stream names. So what do you do after that? You want the data for that time series, right? So you have the demand over time, and you want the data out of it. So you're making a call to stream interpolated data. So building, seed, stream name, start time, end time, and interpolation interval. There's some restriction about the API right now because it's kind of new. So you can ask only for at most a month of data. And the time resolution is, the best one is 2 minutes. But probably to do most of the things that you need to do with that kind of data, 10 minutes interpolation interval should be enough. So you make a call and you get the time series back. And then you're using pandas or whatever to do the analysis, visualization, analytics, so on and so forth. Any question at this point? Yeah. Yeah, so interpolated data, you're going to give it kind of the name of a stream, right, that you're interested in, and you're giving a start time and end time. So the time difference between those two cannot be more than a month, so 31 days exactly. Okay, otherwise the API will tell you, please use something smaller. Okay. So I can show you a bit about what I just told you about. So here we see the list of buildings. Here we see the list for building the seed, so chilled water, electricity, steam, right? All the buildings. So the list of all the streams for the ARC center, okay? By default, if you don't put any C, it's electricity. So if you just care about the electricity, you don't need to specify, and you'll get the list of streams. So this is what we care because OCS, so which stands for OSIsoft Cloud Service, this is the information you need to get the data. And here we're getting kind of, for demand, for example, for that building, this is the name of the stream. And the next steps is what do you need to do to connect to the cloud service and get the data back. So you need a bunch of packages, Python packages. You need also a configuration to connect to, but there's 2 missing pieces. So since that thing is on GitHub, we don't publish client ID in secret for obvious reason. So you just have to go, there's a link in that page that gives you the OCS credentials. So you just replace those, don't replace me with client ID and secret ID, and you'll be able to make a connection to OCS to get your data. So once you get the data, you're receiving kind of a JSON that looks something like this, right? And from that, it's easy then to read it into Panda and do whatever you need to do. And we're just showing people, since you're restricted to a month at a time, how do you build data for a year, 2 years, 3 years? Just make calls and depend. And some things you may need to do the work. How to do a plot. There's multiple libraries out there for Python. This is an example how to do it with Plotly. And also, it's kind of important because of buildings, you have also a stream just with the outside temperature at UCDavis every time of the year. So you can match and see if demand is increasing when temperature goes low, things like this. So there you go. Any question at this point? Yeah?
Can we change the interval of data? So instead of every 2 minutes, can we get every
Yes. Yes, so the time interval can be smaller than 31 days, but not over 31 days.
No, no. I mean, every 2 minutes, can we change that? You change the step size.
Yes. You can change the step size, but not lower than 2 minutes. Which is kind of the maximum time resolution of the data itself. So. The data set goes from the beginning of 2017 up to the beginning of 2020. So you have kind of a 3 years of data. Of course, depending on the building, some starts at the very beginning and some others, there may be gap in the data. So this is all stuff you're going to find out looking at the data set.
Do we have data for 2020? Do we have data for 2020?
The question is that, is there data for 2020? Just a few weeks at the beginning, but that's about it.
Is it up until now?
It's not up until now. Next year will be.
You comment on the real-time prices, too. I don't think I pricing with that.
Yeah, so there's also real-time, what's in there exactly? Over time, the price that you pay electricity.
Yeah, I'm gonna go back to the, I forgot to mention this. It's on the yes. Yeah. So I forgot to mention this, we also have, in general, we pay like a flat rate as a university that's given to us by our power provider, WAPA, Western Alliance for Power Association or something like that. But they actually roll all of our pricing into like one lump sum, and we kind of can extract that out and get an estimate on what we would pay on a 5-minute interval. And so there's this additional Excel spreadsheet in here that actually has 5-minute power pricing, which is I think potentially useful for you guys if you wanted to try to figure out like when to shut things off or how to save money when pricing is less expensive. So you should be thinking about how to cross-reference a file like this into your data set. It's available on that website as well.
That's the price for electricity only, right? Not for steam or
Well,
chilled
keep in
water?
mind, so we, for chilled water, we have central chillers that use electricity to make chilled water. And that's why you really need to roll everything into one, right? So you need to roll in the cost of, everything is converted from kilowatts or from, in the chilled water sense, it's already in BTU, kBTU. So everything is chilled water, steam, and electric is all going to be in kBTU. Yeah, so you would need to convert from, there's actually just a simple conversion from kilowatt hours, or in this case, I think it's megawatt hours per dollar per megawatt hour in this spreadsheet. Convert from that to kBTU. I think it's like 3.41 or something like that. You can actually just look that up online, what the conversion from kilowatts to kBTU is relative to BTU. Good question.
Any other question at this point?
Yeah, so this notebook that we made, you should be able to, in theory, run through it line by line. So you shouldn't get any errors. If you do get errors, come talk to us, and we'll help you walk through that. But it's a really good starting point for just getting all the data and really understanding the data set as it is. You can download that from the website.
So just to wrap up, we'll be having prizes for the best use of the data. First place is $500 Amazon card, then $300 and $200. That's a per team clause. I don't think you're prohibited from joining two challenges at once. So like if you take our data and use GCP to do some machine learning on it, that would be really cool. Probably be interesting. And join those together. We have a pretty big staff here, so come by, see our table. It's up by the front, by the where the projector was and the stage was, and we'll be able to answer your questions. We'll have people from UC Davis and OSIsoft there to answer your questions. And in years past, this year is no guarantee, but years past we've had somebody man the desk all the way through. So we'll do our best to support you guys whenever you need the help. So with that, we'll turn it off.